Hello. So I want to introduce a cool concept and project that is expandable to a whole bunch of other kind of cool projects, and yet is really simple so far as the amount of hardware and building. Um, in fact, it's so simple I thought I'd actually do it initially on just an UNO, in part because some of our colleagues aren't fortunate enough to have their robot or teensy, and some of them are getting something like this UNO here, which is really affordable. So if you can do it on an UNO, you can probably do it better on a teensy, which has got a lot more power, a lot more memory, a lot more of everything. So what I want to do is talk about data logging. Okay, so all of these devices all have a special allocated memory section which is not volatile. All right, so I can put stuff into that memory, I can turn it off, and I can forget about it for a day, a week, a month, or whatever. And when I turn it back on, that information will still be there. I don't have to reload it in from the computer. It stays in a separate section of memory, which is called EEPROM, and it just stays there with the powers off. So we're going to put some information in it. We're going to log some data over time, and then I'm going to probably use a photo-resistor like this one, I think. And I'll set it outside, and we'll see the passing of the sunlight or some other thing, and I'll come back and we'll get that data out of it. So to do that with an UNO, okay, if you have nothing but an UNO and a photoresistor, you can already build a data logger and do something kind of cool with it. So let's get started. First thing I'm going to do is go to one of my favorite examples, and we're going to come up here to basics, and we'll do the analog read serial. All right, so I'm going to build my data collector using just this photoresistor. And what I'm going to do is I'm going to plug it between pins A0 and ground, just like so. And that is all that I need to get this thing started. All right, so I've got it between A0 and ground, and we're going to see what kind of value we get out of it real quickly. So let's go down here. We're going to use this. It's already set to A0. I'm going to slow that down significantly. All right, so we can actually see the data being displayed. And this is super important. If you're using your teensy and you have a voltage divider board, you do not need to do this next step. But on this, where we just have this photoresistor and no other external components, we have to set that pin to a charged state. Okay, and that is done with pin mode. All right, and which pin are we talking about? We're talking about A0, and A0, and we want to put it as an input underscore pull up. Okay, by doing so, we're going to actually hook a resistor hooked to voltage to that pin, and that's going to charge that pin, and this photoresistor is going to be a path for those electrons to make it to ground, depending on how much resistance it is. Some electrons are going to go quick, some are going to be held back if the resistance is high, and then we're going to be able to determine the state of that pin by simply asking it an analog read. If the resistance is low, all those electrons are going to ground and the value is going to be low. If the resistance is high, those electrons are backed up on that pin, and it's going to give us a higher value when we read it. So let's load it up and see what it does. I should have preloaded this, I'm sorry. Not exactly sure what that was. Let's try this again. Probably because I opened the window at the wrong time. There we go. Okay. And you can see it's working pretty well, right? So this is not in any kind of light here. It's actually in the shadows of my camera. I don't even have my desk lights on. But if I put my finger on it, we get a value going up to about 860. And then, of course, if I put my hand off, and I probably aim it a little bit differently, I can get some different values out of it. All right, so clearly it's set up and it's working. We can use this now to collect data on the amount of light. All right, So now the next thing is, let's open up an example in the EEPROM. Once again, we're going to start with examples. And we want to scroll down to EEPROM. And then let's do just a simple one with the write. Okay, I was going to write to EEPROM. So we've got it set up. We've got the include. This is going to open a library that allows this all to happen. We're going to create an address. So the address 0, that's our starting point. Think of the address as rows on an Excel spreadsheet. Okay, so we're going to start at 0, and then we're going to work our way down that Excel spreadsheet. And then we're going to fill in the cells. All right, so the address is going to be that row on the Excel spreadsheet. And then the data, of course, is going to go in the cell. And, here's the thing. I don't know. These have different amounts of memory. I actually don't know how much memory an UNO has, but we can find out super easy, even from this example, because it handily has this piece of code right here. This EEPROM.length is designed to determine the amount of rows that we can collect. How many individual spaces do we have for data? And I'm going to copy that, and I'm going to go up here to setup. And notice that in this particular case, this example had no particular serial output, so it never had a serial begin. So first thing I'm going to do is open up that and get our serial port open, and then oops. Okay, so I think I'm going to go ahead and open up the port, and I'm going to print out the length. Actually, I'll put in there that while not serial thing here. Good gosh. I can't, my fingers are very cold, and my office hasn't, it's probably about 45 or 50 degrees. The heat's been off all night. Okay, let's load this up, and hopefully we'll get the length of that serial, of that EEPROM. I'll open up the window here in a second. 1024, all right? So we can hold 1,024 individual bits of data. So think of that as 1,024 columns on a spreadsheet. All right, so we're off to a good start. Let's close that. Now I'm actually going to go ahead and comment. Actually, I'm going to comment both of these lines out because I'm planning on not having this hooked to my computer. I actually want to have it sitting out, with a battery pack someplace in the yard or something like that. I'll leave that port open though. So let's go on down here. Let's take a look. So this is an important thing to realize. It's going to hold 1,024 individual 8-bit bytes. All right. That means the biggest number that we can get is 255 out of an 8-bit byte, which is exactly why, when we've done analog read before with our teensies, we get values up to 1023. Well, that's 10 bits, so that won't fit. So this particular thing takes and reads the value of pin A0, and by the way, you can just put 0 in there, and then it divides it by 4, so that means it can squeeze it into a value of less than 255. This line right here is going to write that value into the address, and of course here's the value that was collected here, so it's going to write the number into that location. This line here, I'm sure you're familiar with, is going to increment that address value every single time this thing runs in a loop. This is something I may not want, okay? So what happens here is if the value gets up to that maximum, it resets the address to 0, which means it's going to start rewriting over again. I don't think I want to do that. I want it to gather data until it's full. So I'm going to change the condition in this if statement to, well, in case I'm hooked up to anything, I'm going to have it, what do I want to say? Maybe I'll just have it say the memory is full. And I think I'll do a while true right here. And I'll just comment this one out. Excellent. Okay, so this is going to, when it reaches the maximum length of the memory, it's going to put out memory full. If it's hooked to a computer, you'll see it. And then it's going to put in an infinite loop, so that way it doesn't rewrite over the original set of data that we collected. And the next thing is the delay. Well, let's see now. I want to collect data for, I don't know, a few hours. Let's take a look at what we can do. So 1 hour is 60 minutes, and 60 minutes times 60, so that makes it 3,600 seconds, which means that per hour, and which means that it's going to be times 1,000 is going to be 3,600,000 milliseconds. So let's say I want to collect data for 3 hours times 3 hours. Okay, so it's going to be 10,800 milliseconds, and we can collect 1,024 bits of information. So every 10,500 milliseconds, I want to take a data point. So I'm going to go over here, and I'm going to change this to 10,500. Oh, let's just make it 10,500. Okay, excellent. I think what we're going to do is we're going to give it a quick test here. We're going to make sure it's actually working. So I am going to serial print value. We'll do a quick diagnostic. Make sure it starts off okay, then I'll turn it off, unplug it, hook it to batteries, and set it outside. So let's load this up. And oh, look at that. Good thing we checked it, because the other thing I didn't do is keep in mind, of course, that we're going to be using this UNO. We don't have a voltage divider board, so a really important thing to do is we got to set that pin mode. Okay, let's reload that. Excellent. 117. And bring that back down. Let's take a look at the value. Cool. All right. And by the way, it's already getting pretty bright in here. So let me stop this and stop this video. I'll pull this out. We're just going to kill it. I'm going to hook it up to batteries, and I'm going to set it outside for a while. So I'll see you guys in a little bit. Okay, so I've pulled my data logger in, and we're going to look at it. And actually something came to mind I wish I had done, so I'll share that with you. Know where I had it say memory full and while true. It would have been a lot more useful if I had made it, for example, start to flash this light over and over again. I honestly don't remember what time I started, and I don't think I got 3 hours worth of data here, but I'm not sure. So we'll get what we got, and we'll take a look at it. So I'm going to plug it in. Actually, I'm going to wait a little minute. Let's go ahead and load the software we're going to need. So now we want to read the data. So let's go to examples. Let's go to EEPROM again, and let's take a look at read. Okay, so this is going to be fairly similar to the right. We're going to have the library put in. We're going to start the address at 0. Looks like this one, obviously, because it's designed to output to the screen, it already has that. In fact, I'll close that. We'll open it up. It has that while not serial, so it opens up a port. And it's going to go ahead first thing and display the address. It's going to tab it. It's then going to take that value. It's going to create it, compress it into, I shouldn't say compress, it's going to change it into decimal format so we know what that byte actually looks like in digits. Okay, keep in mind this is an 8-bit byte. It's storing it as ones and zeros, so it's going to make sure it displays it as a value that we understand. And then going on down, it's going to increment the address. This looks like it's going to make it loop. Once it gets done, it's going to go back to 0. So I imagine it's just going to loop through it over and over and over again. I think what I want to do is as soon as it gets to the end of the EEPROM, I simply want it to stop. I don't want it to be displaying it over and over and over again. That's sort of silly. Okay. In which case I can comment that out. And delay 500. Wow, I've got 1,000 data points. I don't want to wait that long. Let's make it go like 10 milliseconds. Okay. So keep in mind, as soon as I plug this guy in, it's probably going to overwrite at least the first piece of data because it's going to start running the old program. So we're going to get this thing loaded as quickly as we can. So we're going to lose that first data set anyway. But however, that's probably okay because it was inside. I didn't set it outside. I'm sure it took me some time to do that. And it also took me a while to get it disabled. Done uploading. Let's take a look. Oh, there comes our data. Look at that. Nice. And we'll get that all to load. Okay. So here we go. We got our data. It looks like, yeah, it looks like I did pull it too soon. We got some zeros in there. Oh, look at that. Oh, look at this. This was probably me. This was outside. Then I came inside. I have this gantry in my way that I had to move. So it looks like it took me 4 readings before I even got inside and got it unplugged. I should have unplugged it outside. That wasn't thinking very well. Let's go up to the beginning. And sure enough, it looks like we've overwritten at least 1 data point. So it's inside here and it overwrote that very first one when we plugged it in, I'm going to guess. Or that might have been when we started too. Okay, so now let's do something with this data. So I'm going to go ahead and, now this is kind of odd. Normally I did an experiment before. I would just do this. I would select all, Control A and Control C. And you might be able to do that. But I know when I'm shooting these videos and I've got this thing online and I've got Teams running and all the other stuff, I'm running out of memory. So it's been giving me some difficulty when I try to copy and paste too much. So I'm just going to copy and paste, say 300 of them. That should be good. I just have to do it a couple of times then. So let's get 300 of them. Alright, copy, and let's go over here to Excel. I'll move Excel in here, and let's paste it right here. Let's see. Yeah, that worked great. So Unicode text. So let's go get some more. Move this out of the way. Let's go from 300 to 600. Again, you guys can probably just copy and paste the whole thing. I'm just sucking down resources here. And I couldn't gather it last time I tried. Alright, so up to 600. We'll scroll this down to the bottom of its list. Alright, and let's go from 601. I'm going to guess we can go the whole rest of the way, because if I'm not mistaken, it kind of crashed at some point because I pulled it too early. Oh, it's really bright outside. I didn't plan on those numbers being so low, but we're still going to get data. There we go. Oh, well, yeah, so I'm going to leave these last 4 out because it's probably just junk when I was trying to get around my gantry. And let's move this Excel back here. Scroll it on down. Okay, there we go. Let me make this Excel spreadsheet so it fits in this window. And we'll do a really, really fast plot. Nothing special. Alright, so make sure I don't have any junk data at the bottom. I don't have any junk data. Let's get rid of it. Yeah, we're good. So I'm just going to essentially copy. I'm going to go ahead and just plot all of this stuff here. We'll do a real fast and easy graph. I guess I should have just selected the column. It's a lot of data. Alright, and let's insert a graph. How about just a line graph? There you go. Okay, so you can see it got brighter and brighter and brighter. The resistance got lower and lower and lower. This must have been maybe when I was going in and out of my door, I blocked it at some point, or clouds or something like that. So it works great. So with this teeny little piece of information in this very small demonstration, you can build data loggers that can do things like collect temperature, collect daylight, you can span the times, just have to think about the increments, the total number of spaces you have available. And I'll show another video here shortly that allows you to take more than just a single piece of data and store it into a cool array. So hopefully I will see you again soon, and have fun.